Hi, so today we're going to talk about our 1.1 notes, which are about absolute value. Just a refresher from last year and from our word wall is that we know the words integer and absolute value. So an integer is going to be a set of whole numbers. So remember, those are going to be counting numbers 1, 2, 3, 4, 5, 100, 27, all of those, and their opposites. And really, opposites mean negative. And since this is an important word, we're going to collect this word by highlighting the new word in green. And then the definition, because again, we want to remember this definition, we're going to highlight it in yellow. So integers are whole numbers and their opposites. So positive and negative whole numbers. Absolute value, though, is something that's very important. Absolute value is going to be the distance between a number and 0 on a number line. And we write it like this, where we have two high bars with a letter inside. This is a letter. That letter represents any number called a variable. Or we might see it as a whole number in there, or we might see it with a negative whole number. You can even have fractions in there. But we want to make sure that those bars are taller than the numbers. So what's important is that this word distance. Distance is a measurement, and with this measurement, it's always going to be positive. If you think of a car, no matter what way I drive, whether I drive to my mom's house or from my mom's house, my car will be added miles. When I drive to my mom's house, I will put 99 miles on my car. And when I drive back home and I go the opposite way, I still add 99 miles to my car. And so it doesn't matter which way we're going, distance is always positive. So again, absolute value is always going to be positive because it is a measure of distance. And again, that is a new word, so I'm going to highlight it in green. And then I'm going to highlight in yellow our definition. So down here we have an example. Notice how we have the high bars around -4 and high bars around 4. Those are absolute value bars. This is saying we're finding the absolute value of -4. And that distance, 1, 2, 3, 4. My distance from 0 to -4 is 4. So my answer is positive. And same thing over here. The distance from 0 to +4, 1, 2, 3, 4 is still 4. It is always positive. Now we're going to take a look down here to our example. Find the absolute value of -3. They say to graph it on a number line. So here we go. We're graphed. Then we're going to find the distance between -3 and 0. So again, how far did I travel? 1, 2, 3. I traveled 3. So my absolute value, again, I have it in high bars. The absolute value of -3 is +3. I can do the same thing with fractions or decimals. I want the absolute value of 1 1/4. Again, that is down here, 1 1/4. So I'm going to plot 1 1/4, and I'm going to see how far away that is. So here is 1/2. Notice the number line goes up by halves. So 1/2, 1 whole, and then 1/4. I traveled 1 1/4. So my absolute value is 1 1/4. You can do the try-its on your own. Take a moment. Pause the video if needed. We again want to know how far are these numbers from 0? Because that's what we're asking. Absolute value is how far. So in this one, the absolute value of 7, the distance is 7, always positive. The absolute value of negative 5/3 will be 5/3, always positive. The absolute value of negative 2.6 is positive 2.6, always positive. You can go to the next page. On this next one, it says comparing rational numbers. So we are going to compare. I'm going to have you highlight that in orange because that's an important word for us too. When we are asked to compare, they're going to want us to use our inequality signs or equal sign. So they want to know, is it greater than or less than? Greater than or equal to, less than or equal to, or maybe it is equal. And they want us to compare the absolute value. Notice again, we have our bars. That's how we know it's absolute value. And 3/2. So first things first, we talked about in GEMDAS that grouping symbols is first. And believe it or not, absolute value bars are grouping symbols. So what's going to happen is that we need to do absolute value first. Always take the absolute value first. And so we need to know, what is the absolute value of negative 2.5? And again, my distance from negative 2.5 to 0 is 2.5. It's always positive. And now I can compare 2.5 and 3/2. 3/2 is 1.5. What they did is they graphed it. They said, okay, 2.5 would be 2.5. It's between the 2 and the 3. And 3/2 would be, let's see, 1 is 2 over 2, plus another half would be 3/2. So I could see which one is larger. If I look, I'm further to the right with 2.5. So that would be my larger number I compared. Down here on number 5, we're going to focus on that one together because that one looks a little bit different. If you notice, we have a negative outside the absolute value bars. Just like I said, grouping symbols come first. So we are going to look at that, and I want to take the absolute value first. The absolute value of 1/2 is 1/2. And then I can bring down my negative. So even though I said absolute value is always positive, absolute value is absolutely positive, that doesn't take into account if we have a negative outside. First, we do the absolute value, and then we do anything outside of it. So this is negative 1/2, and this is negative 1/4. And we have to decide which one is larger. And to do that, I'm going to look down here. I, just for the sake of this, am going to make a yellow dot for negative 1/2 and a green dot for negative 1/4. So negative 1/2 is exactly halfway between 0 and negative 1. Right? Negative 1/4 is going to be closer to 0 than negative 1/2. So if I ask one which one is larger, or I compare them, I want to know which one is further to the right or further to the left. One thing we need to know is that the left side is the less side. So whichever one is further to the left is less, and in that case it's negative 1/2. So negative 1/2 is actually less than negative 1/4. Even though we think of, 1/2 is larger than 1/4, it's going to be the opposite idea because we have negatives, and negatives mean opposite. So go ahead and try number 7 on your own. First, find the absolute value of negative 4.5. Be careful, there's a negative on the outside. The absolute value of negative 4.5 is 4.5, and then I have to carry down the negative. And then 7, there's nothing around it, so we keep it 7. Which one's larger? Well, 7 is larger. It's going to be on the right side, where negative 4.5 is on the left side. So it's going to be 7. What about in number 9? What do you guys think? Find the absolute values first because, again, grouping symbols come first. They're both 9, so we can say that they are equal. We're going to skip ahead for right now. We'll come back to the other ones in class. We're going to look on the back. So it says a moon has an ocean underneath its icy surface. Scientists run tests above, which are going to be positive numbers, and below the surface. Below will be negative. If we're talking about the surface, that means we're talking about 0. That's going to be the number we use for the surface. The table shows the elevations, or how high or deep each test is. So which test is the deepest and which test is the closest to the surface? So deepest and closest. Those are two different questions. To find which one is the deepest, which is great, they already did this, is that they plotted each one of these on a number line. And they made an up and down or vertical number line, which is helpful because our deepest will be the bottom one, which is this one down here, which is a little bit under negative 5. And if I look here, that's going to be salinity. So I can say that salinity is the deepest because it is the one that is at the bottom of my vertical number line. It is the least. And at top is the most. So I can write salinity is the deepest. Test. So we answered our first question. Now we want to know which one's closest to the surface. And if I look here, we said the surface means which one's closest to 0. And on my number line, I see 2 really close to 0. That's going to be atmosphere and ice. Closest is what we talk about with distance. And if I want to know distance, I want to know absolute value. Which one's closest to 0? So I'm going to talk about their distance from 0, which is how we describe absolute value. So I want to take the absolute value of both of these numbers. The absolute value of 0.3 is 0.3 because it's always positive. And the absolute value of negative 0.25 is positive 0.25. And if I look, if I'm not quite sure, I can think about this in terms of money. Would I have more money if I have 30 cents or 25 cents? 30 cents. So this is further from 0. 25 or 0.25 is going to be closer to 0. So since this one's closer to 0, ice will be the closest test. So I could say the ice test is the closest to the surface. So sometimes we're going to have to compare numbers by looking at where they fall on a number line. And sometimes we're going to have to find the absolute values and then compare absolute values on a number line. You do have homework from here, and your homework will be evens. So the ones that I highlight, you will do for homework. And that is all.